My name is John Dewey. I am a PhD student in materials science at the Department of Chemical Engineering and Materials Science here at the University of Minnesota in the Twin Cities. So I research electronic and magnetic materials. Now there are tons of electronic and magnetic materials in the world, and I work on just one small research corner, which is the thin film perovskite oxides. These oxide materials are special because we can get them to behave all kinds of different ways by playing some science tricks on them. We can play with the chemistry, strain, layering, or electric fields. And these materials respond to those different things we do to them. And that way we can control them and we can get them to behave in new and useful ways. The tools that I use at this university are the same ones used to make computer chips or smartphone screens or thin solar cells, things like that. In our lab, we want to discover new fundamental science about the building blocks of electronics so that people in the future can build a better solar cell or make a new kind of computer or make something totally new that we can't even imagine today. You don't have to have your life perfectly mapped out in high school. I didn't follow the path that I imagined for myself in high school, but keep doors open for yourself. That means keeping your grades up even if you don't love this class or that class. Keep trying things that are interesting to you, and eventually you'll find something that really motivates you. And if you kept your doors open by working hard in high school, there will be fewer barriers in between you and your dreams. So some of the big challenges we face in the fight against climate change are materials issues. Say we want to use more solar energy, and we want to capture all that energy and store it in batteries and drive cars with them. A big problem today is that those batteries can be pretty big and bulky, or they might be very flammable, or they might contain some rare elements. These are all materials problems. So a big challenge is to discover and invent new battery materials that are lighter, or that last longer, or charge faster. This way, storing all that energy becomes easier for society. Now, you don't need to be a material scientist to invent a battery or a new and better battery, but material science attacks the problem from many different angles simultaneously. We work very hard to try to connect the way that you make a material with how it looks microscopically to the way that it performs when you actually try to make something useful out of it. And so in that way, material science is very powerful.